question 24 is like should be an easier problem. So it's like a geometry problem, and we're given circle centered at A and B, each have radius 2 as shown, and point O is the midpoint of AB, and OA is 2 root 2. Segments OC and OD are tangent to circles, center at A and B, and we're given that EF is a common tangent. Want to know what is the area of this shaded region? So this shaded region thing is kind of like hard to deal with, because like normally we know like triangles you can write as like 1/2 base times height, square is like just side length squared, rectangle is length times width. But in this case we have a weird irregular shape, so we don't have like a formula to just directly like plug in and like get our answer. In these cases, you either want to take the shape that you want to find the area of. The first strategy is to divide it into smaller regions that you know how to find the area of, and the second way is to take a region you know the area of and chop off regions, like subtract off areas. So in this question, we're going to try the second approach. The idea is we can, as a very common like math problem solving strategy, if you have like a common external tangent or just tangents in general, you get a circle and you have like a line tangent, right? So it intersects a circle at one point, then it's almost always, it's a good idea to take the center of the circle and connect it to the point of tangency, because that's going to give you like a right angle. And right angles are good because they can simplify a lot of calculations. So if we use that property here, we notice that that EF is tangent to the two circles. So if I draw AE and I draw BF, these are going to be perpendicular to EF. And now what we can do is we can kind of like notice that AO is 2 root 2 and AE is 2. So AB is going to be 4 root 2. So the area of the rectangle is 2 times 4 root 2. So the area of the rectangle is 8 root 2. So now all we have to do is we can subtract off like these blue regions here, and then we would get the area of the shaded region. So we only have to find the area of one of those regions, because then we can just double it by symmetry. So to do that, we can kind of draw again. We're going to use that trick where if we have a tangent line, we're going to connect the center of the circle to the point of tangency. So we're going to connect points A and C together, and that's going to give us like another right angle. And we get AC is 2 because that's a radius of the circle. Then we can find that OC is also 2 just from the Pythagorean theorem. Just from the Pythagorean theorem, you get that OC is also equal to 2. And notice that like you have an isosceles right triangle. And remember, when you have an isosceles right triangle, the two base angles are going to equal 45 degrees. So this angle over here is going to equal 45 degrees. And this angle here is going to also equal 45 degrees, right? So the idea now is like the area of like this green triangle here, it has a base of 2 and a height of 2. So the area is 1/2 base times height, 1/2 2 times 2. That's going to give you an area of 2. Then you have like this, like, we'll say this yellow sector here, right? This yellow sector, we said that it has an angle of 45 degrees. And it has a radius of 2. So the area of a whole circle would be 2 squared pi, which is 4 pi. But like, we're not considering the area of a full circle. We're only considering 45 degrees of a whole circle. So we would multiply this by 45 over 360. And if you do that math, you would get pi over 2 for the area. So if you do 2 plus pi over 2, that would give you the area of one of those regions. Remember, since we have 2 of those, right? We have one on the left, one on the right. So we're going to double this. And we get the area of the total unwanted region is going to be 4 plus pi. So now we can just subtract that value from the total area of the rectangle, and we would get an answer of 8 root 2 minus 4 minus pi. And that would give you like choice B, which is the correct answer.